Kotlin Multiplatform video. So in this video, we're going to learn how to implement a persistent database in Kotlin Multiplatform project. So specifically, we're going to use Room database in order to create this application. So let's get started. Okay, so the first case here, we have to get our versions catalog and add the dependencies which we require. Okay, so here I have added several libraries which are going to help us in creating this project here. So you can get this inside my GitHub repository, which I have linked down the description box below here. So basically here we have the Kotlin coroutine swing, which is specifically going to be useful when we're using this in a desktop environment. Also, we're going to use a ViewModel as in Android, and also we are going to use navigation for navigating, and also here we are passing a Room database and also Kotlin symbol processing units, which are going to help us to process those Room database annotations and other things. And then we are going to use this SQLite and also this one Kotlin coroutines that are going to be used in Android and iOS specifically. So for this case, I have added these dependencies which are actually crucial in order to get started. Now after that, let's go to our Compose app here, which is going to help us to configure this. So I'm going to show you step by step on how you can configure your dependencies in order to get started. Okay, so here we're going to add the life cycle and also the navigation, Room runtime, SQLite, and also the Kotlin coroutine call, which are going to be essential to make our application functional. Okay, then inside here, our desktop main dependencies, we're going to add the Kotlin swing. So this one coroutine swing, which is going to be essentially inside a desktop environment. Okay, now after we declare these dependencies, we have to declare the KSP annotation processors. And this one are going to be specifically different to different platforms. So for this case, I'm going to add a dependencies. So for example, here I'm going to add the dependency compiler for Android and also the KSP for desktop. And if you want to also include for iOS and other things, you can use this one here. Okay, so the next case here, we have to declare the schemas we are going to be stored. So we can create here data, which we are going to pass in here the schema directory. So for case, we are going to use this schema directly to save this here. So whenever we compile this and sync the project, then everything is going to go perfectly. Okay, lastly, what we have to do inside here, we have to declare the plugins for KSP and also Room database. So we are going to add these two libraries here, the KSP and Room. So for this case, let's try to sync our project. Okay, so our project has synced successfully and everything is looking perfectly. So the next case, let's start to build our database. So at the end of this tutorial, we're going to build this project here, which is just a simple one to demonstrate how you can use persistent database. So for example, here we can create a node title. So for example, let's call this what is. And basically here we can pass in the description to get the data, for example. Now we can save our node. So you can see here we have our node. And basically let's save another thing, for example. Let's just save this node. So you can see here, we're just saving this. And basically we can perform CRUD operation. So for example, you can just delete this. So let's get started and see how we can build this simple application. Okay, so directly here you can switch between Android and projects. So I'm going just to select here project, and basically you're going to get the view like this one here. So let's directly go inside here our common main, and inside here let's go to Kotlin, and I want to define now the database so that we can just start to work with it. So let's create a new directory. Okay, so for starters, Room database is an SQLite library that provides an abstraction layer over SQLite. So basically, we are going to not interact with SQLite directly, rather we are going to use annotations in order to interact with it. So it's going to help us to provide all of those boilerplate codes and write it for us. So basically, we can focus on writing the functionality of our application. So it provides a compile time verification. So whenever we write a code that is going to be error prone, whenever we have an error, we can easily spot it at compile time rather than runtime and basically fix it before we continue. So for that case, Room database is really crucial. Also, it provides convenience annotations. So we don't have to write boilerplate code in order to access our database. So for this case, we can easily focus on what is the core of our application. Also, Room database has three major components. So the first one is an entity. So an entity is like the table inside our database. So basically we can define the column and rows of our database by using the entity. Then the next case, we have the data access object. So the data access object provides the methods which we can use to interact with our room database. So for this case, we have the CRUD operations which we can easily perform by using this data access object. And lastly, we have our database class which we can use to access our connections with SQLite. So basically, this is like an entry point to use the SQLite. So let's see how we can implement these three objects. Okay, so inside here, our database class, let's just define here an entity, a class. So we can create here a directory. We can call this entity. And inside here, we can create our class, which is just going to be the node. Okay, so this one, we're going to make this to be a data class. And inside here, now we can define the properties of this particular table, which we have. So for example, we are going to define here an ID, which is just going to be an integer. And by default, we are going to give it 0. Also, we can define here the title, which is going to be of type string. And also we have the description. Okay, so we have to tell room database, hey, this is going to be a table inside our database. So for this case, we have to annotate this with @entity. Now, inside here, we can provide the table name. So basically, if you do not provide the table name, then room compiler is going to use this name here to reference the table name. So for example, here we can just call this not table. Okay, so basically these one are going to be the columns inside our table. And we have to define one primary key. So this one is going to be essential. Otherwise, our application is not going to compile. So we have to provide here the primary key. And we want to auto-generate this. So we can rate room database to generate it. So we can just set this to be. Okay, so now we have here our node. The next case, we want to define our data access object, or in short DAO. So we can create here a new directory. And let's call this DAO. And inside here, let's create our node DAO. And this one is going to be an interface. Okay, so we have to define inside this DAO here and specify the methods which we want. So first we have to tell room compiler, hey, this one is going to be a data access object. So for this case, we have to annotate this with @DAO. Then inside here, we can specify now the methods. So we can create just normal method. So let's create here a function and let's call this getAll. And basically we are going to use flows in order to return this. And this one is going to be a list of nodes. Okay, so we have to specify what is this going to be. So we have to tell room compiler, hey, this one is going to be a query method that we want to fetch data from our database. So we can specify here @query. And with this annotation here, we can write an SQL statement in order to fetch this. So for example, we can just write here select. And we want to select everything from our table. So, and here, basically we can specify now the database. So for a case, it's just not table. So this one is just a simple SQL statement. So what we are doing here, we are telling, hey, we want to select everything by using an asterisk here. We can tell, hey, we want to select everything which is available inside the node table. So this one is just the node table which we have defined inside here, our node database. So you can see what we have specified here is the name of our table. And basically that's what we are selecting. So if we have different tables, basically we can write different table names from here in order to select it. So we have to create here a suspend function. Okay, so here we are creating a suspend function. So for example, here we want to call this upset node. And we can easily just pass in here the node. And with the room database, we can specify only the annotation and everything else is going to be written for us. So let's just call here upset, which this one is going to be used for inserting and also updating this particular item here. So you can see here we have to use a suspend modifier because this one is going to be a long running task. And otherwise, our application is going to freeze if we do not perform this. And room database is not going to allow us to perform without using a suspend modifier here. So you can see here we are using a flow and we are not using a suspend. So don't get confused, because here the flow, it has its own coroutine scope, which can easily be used to suspend the operations which we are performing. So basically no need to write a suspend modifier for this case. Now the next case here is we have to specify the delete. So we can create here a suspend function and call this delete note. And here we can pass in the note which we want to delete. And basically you can provide a custom query in order to delete, or you can use the annotation. So this one is just a delete. Everything is looking perfectly. So the next case here is we have to define our database. So let's go inside here and create our app database. Okay, so inside here we have to inherit from the room database. And basically we have to make this abstract. And the next case we have to annotate this and tell room compiler, hey, this is going to be the database. And here we have to specify the entities which we have. So we can pass in here the entities. And for a case we have only one entity, so we can just call here not. Okay, so then we can specify here the version. And for a case we have only one version, so this is the first version. So whenever you write other database and you want to provide the migration scheme, basically you're going to bump up this to version 2 and provide the migration schemas, which is going to help you to migrate to a new version, for example. So for a case, we are just going to pass in this. So these are the crucial steps which you have to do. Now the next case here, we have to expose our methods to access our database. And this one is like the entry point, as we said earlier. So here we can create an abstract function that is just called noteDAO. So if you have several nodes DAO or several DAOs, you can easily just pass them here. And here, whenever you have another entity, so for example, if you have a node 2, then you can just add here another version. So now we have here everything set up for our room database to work. But one thing which we have to do here is to set up the room database for different cross-platform platforms. So for this case, for Android, it's going to be different, and for desktop and also as well as iOS. So for this case, we have to set up this in order to accommodate all the platforms which we have. So for now, what we can easily do, for example, let's just go to Android main. Okay, so for our Android here, we have our main activity. So for our case, we want to create here a new Kotlin class. And basically, let's just call this database. This one's just going to be a file. We're going to pass in here a single function that is going to give us that configuration. So let's create here a function and call this get database builder. Okay, so with Android here, what we have to do is to pass in the context in order to create this. So this is just specifically available in Android. So we can create here our context. Okay, so this one is going to return a room database builder. So for this room database builder, then we have to specify what type is going to return here. So for a case, we have created the app database, which is the database which we have created an abstract class. Now what we have to do is to get the application context. These are just specifically available in Android. So we have to use the context in order to get the application context. Now the next case, we have to specify the database file. So for this case, we can just call this db file. And now here we can just call get database builder. So we want to get the path, and basically we can save it differently. So from my case, I'm just going to call this my room. Then now we can return that database. So we can call here room. And use the database builder to create our database. And here we have to specify that is the app database. Make it more explicit. Now here we have to pass in the context. So we can pass in here the application context. And the name of this, basically we can just call here our database file. And everything now is looking perfectly for this case. Okay, the next case here is we have to go, for example, inside our desktop. Okay, so inside here, I'm going to create a new Kotlin class, and let's call this get database. Okay, so let's create here a function, and basically let's call this get desktop. And similarly, it's going to return the room database. And here is differently, we can use the file system in order to create this. So here basically we can use system, and we want to get the property. So the property here is going to be java.io temporary directory. So inside this directory, basically we can easily save it. So after that, then we can specify the name of this particular database. So similarly as we have created inside Android, so we can just call this room. And here we can just return now this particular database builder. So let's call here our room. Okay, let's explicitly provide the type. So here is going to be the database. And here we have only to provide the name, which is just the DB file. And here there is no need to pass in the context because we are inside the desktop. And lastly, if you have, for example, iOS, let's see. Let's create here a new class. And for this case, we can just call this get iOS builder. Okay, so here we have to define the database file path. So db file path. So here we have to use the ns home directory. And basically here we have to provide, for example, the name of this. So here you can use this and pass in here my room database. Okay, so it's not recognizing this, but whenever you run it, it's going to be configured because this is the path of iOS. So here we can return now again the room database. So for example, let's call this room, we have to use the room object. And we can call here database builder and pass in here the name. And the name is just the DB file path because we have this. Then the next case, we have to define the factory. And here we have to call the app database. And this one are just going to be available inside compile time because they are going to be generated. So we can just call here app database class. Okay, so you can see inside iOS, we have to use this instantiate implementation directly here. So we have to use the app database class .instantiate implementation, which are going to be directly created whenever we build our application. Then the compiler is going to generate these particular classes. So we have set up our database, and now we can easily now communicate with our database. So I want to use MVVM structure. Basically, we're going to have a repository that is going to directly communicate to the database. Then we have the repository sending data back to the ViewModel. Then the ViewModel is going to help us to display the data. So basically, this is just an MVVM structure. So basically, inside here, our common main. Let's go directly here and let's create our repository. So we can create a new directory and call this repository. And inside here, we can create now a new class. Let's call this not repository. Okay, so here we're going to provide the dependency which we require. So for the case, we want to get the DAO. So let's create this to be a private. So we have to get here the not DAO in order to communicate with our database because we have all the methods which we have. So for this case, we can pass in here the function to get all, for example. So our entity here, we have to return the nots. So basically here, we can just call our not DAO. Okay, let's create here a suspend function and we want to save the not, for example. So here we're going to pass in the notes. And for a case, now we can just call here not DAO and call save. And here basically we can pass in the not. Okay, lastly here we can call here the delete not. Okay, so everything here is looking perfectly. So we have the methods which we can communicate to our DAO directly. Okay, so we have our repository. So the next case here is we want to define the view model now in order to start to communicate with our UI. So for this case, let's go inside here and create, for example, okay, let's call this package UI. And inside here, let's create a new directory. Let's call this home. Okay. Now let's create here our not view model. Okay, so this not view model here is going to receive a variable. So let's call here the private. Okay, so this class is directly going to inherit from the view model class. As simple as that. So if you are familiar with Android, then we have everything here as the view model. Okay, so the next case here is I want to create a data class that is going to hold up our state. So we can create here a data class. So basically we can easily expand this. So let's call this node state, for example. Here we're going to receive the nodes, which basically is going to be a list of nodes. And by default, this is just an empty list. So if you want to add other properties, then you can easily just create those properties from here. Now, after that, we have to create the state that we can keep observing it. So we can use a mutable state flow in order to observe this. So I have here a live template for this. So for example, I'm just going to call this node state. And here basically we can just call here our node state. Okay, so everything is looking perfectly. So here we have the mutable one, which we can easily change it. That's why we kept private. So we don't want to mutate our state outside of the view model. Then here we have the read only, which can be only read. So we cannot make changes from this. So we are going to avoid a lot of bugs for using this particular architecture here. Okay, so whenever we open up our application, so we can call here the init object. Basically, we can initialize everything. So we can just call here view model scope and launch. So basically here, if you understand coroutines, basically whenever we want to call a coroutine, we have to call a scope in order to launch it. So that's why here we're using a view model scope. So for here, we can just call now our node repository and we want to fetch all the nodes. So we can call here get all nodes. And here we are getting a flow. So a flow is just a called coroutines. Basically means it's going to emit the values only when it's going to be collected. So for this case, we have to call .collect in order to collect the data to start emitting the values. So here we are emitting our values and basically we are going to receive the nodes. Now we can change our node state and we want to call .update. So basically here we can update our state. So we can just call it .copy and copy it, basically pass in here the nodes. And that's how we change our state. So here we can provide other events to update our state. So for example, whenever we want to save the data, so for this case, we can just call here save nodes. Okay, so here we can call our view model scope.launch. Basically, we can call now a node repository and we want to save the node. So we can just call here save nodes. And we have to create a new node. Okay, so here we can pass in the title. So this is how we can save the node. And here we can create another function to delete the node. So this is how we delete it. So as simple as this, we are following an MVVM architecture and everything is looking perfectly. Okay, so I can see here we have to provide the parameter names whenever we use copy. Okay, so our view model is complete here. And our view model provides here a parameter basically. So we have to create a view model factory in order to provide this particular view model and instantiate it. So if you're coming from Android background, you know this. And basically in order to create this, for example, if you're using a dependency injection library, then this one is going to be performed automatically for you. But because we're not going to use a dependency injection library, so we're going to have to provide this manually. So for this case, we can create here a class. Let's call this not ViewModel factory. And here we can create a private variable. Okay, so here we're going to inherit from the ViewModel provider dot factory. Now here we're going to override one method that is just called create. So basically here, whenever we want to create this, then inside here, let's call return, and we can instantiate now our view model. So let's call here not view model and provide the not repository. So let's call this not repository. And here we have to call this as T in order to force it. For that case, we can just uncheck this because it's not going to change anything. Okay, so here we have instantiated our view model. So for this case, we can now provide our databases. But because the database is different, it is created differently from different platforms. So we want to do this directly inside our app. So for example, inside here, our app, whenever we instantiate this, so all of the platforms, they are going to call this app here. So basically this is like our entry point. So we can just call here, for example, inside this app and provide the database builder directly from this constructor here, because this app here is called from different platforms. But this one is going to be not clean. So we can create a class that is going to act as our graph that provide these dependencies. So for example, here we can easily create this class inside here. So inside here, let's create a new class, and this is just going to be an object because we want a singleton pattern. For this case, let's just call this graph. Okay, so for example, here we want to get the database. So we can call here let init variable. And we want to get our not repository. So for example, let's call this repository. So we're using a let init variable. That means we are going to initialize later on, because whenever we instantiate, for example, Android, then we want to instantiate also this. So we can create here a function that is called provide not repository. And basically here we are going to get the database builder. Now here we want to get the database for each platform. So basically now we can just directly go inside here our database. So inside here our common, we can create another function that is called provide database. So we can get the specific database from each platform. So here let's create a function and call this get room. And here we're going to receive a builder. So for this case, we can build now our database directly. So we're going to receive a builder, which is going to be specific. So one thing which we want to do is to set the driver. So here we can call bundled SQLite driver. Then the next case, we can provide here the set CRUD in context. So basically here we can call dispatcher.io. And now we can call here .build. So basically now everything is looking perfectly. So we can go back to our graph. Now we can call here get room database. And here now we can pass in the database builder. And we can provide now our repository. So we can instantiate the repository. So let's call here our node repository. And directly pass in here. Oh, sorry. We have to pass in the DAO. So we can call here our database, but not DAO. So basically here we get specifically from each platform, and basically we're going to call this graph. So whenever we compile to that platform, then we can get specific. So we have to set this graph. So we can go inside here Android directly. Let's go to Android. So inside here Android, we can create here a new class. So let's insert here new Kotlin class, and let's call this. Okay, so this one is going to inherit directly from the application class for Android. Okay, so inside here, the onCreate. So we're using this node class here in order to provide this directly whenever we are inside there. So here we can just call our graph and provide our node repository. So here we can call get database builder and provide the context. As you remember, we are required to pass in the context. So this is just for Android. And basically we have to go to manifest, Android manifest, to register this new class which we have created. So inside here we can provide the name .NOT application. So this one is going to save us a ton of time. And after that, then we can go to desktop, for example. Okay, so inside here, let's go to our main class. And here we can call our database. And here we can call get desktop builder. Now we have our builder. We can instantiate now our repository. So we can call here graph.provide node repository and basically pass in here the database builder directly. And similarly, we can do this for iOS. So we can just directly go here to main view controller. So here we can call our graph. We can call provide node repository and call here get iOS builder. And everything is looking perfectly. So whenever you use a dependency injection regularly, you don't have to do all of this. And because we are using a manual dependency injection, that's why we have to provide all of these dependencies directly. Now we can directly go inside here our app and start to build the application. Okay, so inside here, our app, we want to delete everything. Okay, so we're going just to leave here our column. And basically here now we can get the view model. So let's create here our not view model. Okay, so we can use the view model compose. That is just easily. We can provide here the model class or we can provide the factory. So basically here we can just call factory. And instead of instantiating this not view model directly here, we are just calling the not view model factory. Now inside here we have to provide the repository. So to do this, we can use our graph. And since we have already instantiated the repository, so we can just call here graph.not repository. Okay, so this is not going to be a Lambda function, so we can just delete this and directly provide here. Okay, so we have to explicitly specify the type of view model that is going to be returned. So here is just the not view model. And here we have our view model. So we can start now to create our screens because here we have our entry point. So for this, I'm just going directly inside here our app. So let's go here to our UI and here let's create a new Kotlin class. And here we can call this home screen. Okay, let's create a new composable and let's call this home screen. Okay, so here for our home screen, we can pass in here a view model, which is just the not view model. Okay, so we have to get the state from the view model. So we can call this not state. And we can use directly here a by in order to get the state directly. So we can call here a view model, but not state and collect here as a state. And here we have to import the get value. Okay, so inside here, I'm going to place everything inside the column. Then we can specify here a modifier. Okay, so we have here two variables which we want to keep state of. So that basically is the title and also the description in order to display it. So we can create here a state. So that is going to be a title and set title. And here we can call remember savable. Okay, so this one is just going to be a mutable state. I'm going to duplicate this for description. Okay, so here we have our state. The next case, I can declare a CRUD here. Okay, so we want to fill the max width and give it a padding of 16 dp. Okay, now we want to create the input field and basically here we can create a row. Let's give it the horizontal arrangement. And we want to use a space between. And we can align them center vertically. Let's give it a padding here. So first we want to fill the max width and give it a padding of 80 dp. Okay, so here we're going to nest another column in order to show those two text fields, and after that then we are going to show the button at the right hand side. So for this case, let's make this, let's give it a modifier, and we want to give it a weight so that it cannot push that button away from here. So we can give it 1F, and also we can make the field to be false. Okay, so here we can create our first text field. So for the value, here we can pass in the title, the on value change. Basically, we can just call here the set title, and we can pass in here a label. So for a label here, we can pass in a text. Okay, so we can just call this not title. And for the shape, I want to use the rounded corner shape, and here we can use 80 dp to give it that smooth round corners. Then I want to change the colors. So here we can use text field defaults, and we can change the unfocused label color, and here we want to use transparent. Okay, so here we can use the focused indicator color, and here the disabled indicator colors. So I don't want to show that indicator. So basically we are passing here to be a transparent one. So we have here our first text field. So the next case, we can add just a spacer. Now again, we want to create another text field. So we can just easily copy this. So instead here of title, we can just pass in here the description. And that is just the node description here. Okay. Now we can just collapse this. We want to create another button. So we can create here button. And for whenever we receive here the on click, let's provide the name of this button. So we can just call this save note. Okay, I want to give it a padding. So we can just call here modifier.padding and give it a padding of 80 dp. Now here, whenever we have the on click, so we can save the the note. So we can call here ViewModel.save note. So we have to pass in here the title and description. So we can pass in here the title and description. Okay, so we have here our first item that is going to be the input fields. So we can create here another spacer. So let's give it a padding, a height of 16 dp. Okay, so below here we can create another CRUD. So similarly here, I want to copy this. Let's press Ctrl C and paste it here. So this is just the modifier. Okay, so to display our data, I'm going to create a lazy column. So we can create here a lazy column and use our item. Specifically here, we can pass in the note. Okay, so here we're going to receive the note. So we can create here a separate composable to display the note item. So let's just go below here and create another composable. Let's call this note item. And here we're going to receive the note. And also we can pass in here the event, the on note click. So here we can fill the max width and give it a padding of 80 dp. And also we can give it the on click. So basically we can just pass in here the on click. Okay, so this requires to use opt-in, so we can just call that opt-in. Okay, so whenever we have the on click, so we can just call here on not click and invoke it here. Now inside here we can create a column. Okay, so we can just give this padding and no need to give this padding here. Okay. For the next case, we can just display now our text. So we can just call here, for example, text, and here we want to pass in the node title. Let's change the style of this title. So here we're going to use a header 6. So we can use typography. Okay, let's give it a 4dp spacer. Here we can pass in the node description. And we can change the style. So let's use here. And here we can use body 2. And here we can pass in here divider. So we can just fill the max width. Okay, so directly we have here the items. Now we can directly call the node item. And here we want to pass in the node. And here we have the on click. So we can just open up here lambda syntax. Now we can just call here ViewModel. Delete node. And here we can pass in the node that is required to be deleted whenever we click this. Our home screen is complete, so we can easily go to our home directly. Okay, so here we can shift to our app. So inside here our app, we can now call our home screen. So let's call here home screen. So here we can pass in our node view model. You can see everything is perfectly set up. Okay, so we can run here inside our Android application. So let's click here run. And while we're waiting for this to run, we can build here for desktop also. So let's go to configuration here and edit configuration. Now we want to click new here in order to generate a new configuration. Let's select Gradle. And here we can call desktop run. And here we can call the main class. Okay, so our app is launched successfully for Android. So basically here we can pass in the node title. So for example, let's write here title. And here let's write description. Let's click save node. And basically you can see it's appearing here. So let's click this a bunch of time. Okay, so you can see they're appearing. Now let's click, for example, here you can see it's deleting. And everything is working perfectly. Now let's try to run this for our desktop. So we can use this configuration here, desktop run, which we have created. Let's run it also there. So here it's run. So basically whenever we click here, we can get our node title. But I'm seeing here, it's not displaying here. For example, whenever we are not selecting this. So I think there is something which we are doing wrong here. So let's directly go to our home screen. Okay, so here I want to remove these indicator colors. So unfocused indicator color and not the label color. That's why we did not see those. So also here it's not label, so it's indicator, unfocused indicator colors. Let's rerun again. We have rerun this in Android and you can see our data is persisted across configurations and also whenever we kill our application, so the data is actually saved. So we are saving this directly to our database and we can try to relaunch again, for example, inside here our database by using this desktop run. And let's click run again here. So as you can see, everything is persisted. So for our desktop, the data is actually persisted inside our desktop environment. And for Android, similarly, we save it in Android environment. So everything is working perfectly. And if you have an iOS, basically you can just run it and save it. So for this case, let's leave it here for this video. If you find this video actually helpful, please don't forget to provide a like, subscribe and share for more videos. Next video, we're going to learn how to communicate to an API, basically API calling from a desktop environment, also Android environment, and generally cross-platform. So in the next tutorial, we're going to learn how to communicate to an API. So basically, we're going to use Ktor client in order to communicate to a mail database that is going to give us the information. So we're going to learn how to convert JSON to data classes and work with it inside Kotlin. And also we can learn how to actually fetch images directly from the internet by using Coil image loading library. So for this case, we can get this data and actually view the more informations which we have here. So basically, this one is going to be packed with a lot of information. So see you next there. Bye bye for now.